Hello. Yeah. Good morning again. This is Swapnil and I will be taking today's session on boundary conditions in Midas. So before starting and moving forward for today's session, let me just tell you the purpose and why there is a particular session on boundary conditions alone. As you know, in any model, after completing the modeling of your nodes in element and creating your model, your sections, material properties, boundary conditions play important role in the behavior of your structure. Whether the force transfer to your substructure is high or the forces which is getting resisted by your girders, all these are dependent on how your boundary conditions are provided, how the rigid links are taken, how your integral supports are defined, how your temporary supports are defined. Those parameters are important. So that's why we have a particular session on boundary conditions only, so that these problems can be tackled and rectified. Now let us see what are the things that we are going to cover today. If there's any additional points that we will be learning. So those are the motives for today's session. So let me just start with it. So yeah, contents. I've tried to keep this session brief as possible. So first we will start with what are the different types of support available. Then where are the practical applications of this support. Then some few examples like in project condition kind of thing. Where can we have it? And then we have a FAQs. What are the frequently asked questions by our clients while using the software. So this is a general overview that we will be seeing. I'll focus more focused on explaining the different options. I'll be open to take any questions during the session so that we will have an interactive session and other users can also see what are the questions or problems faced by the clients while modeling. Yeah. So if my voice is audible and the screen is visible, I will be starting the session. Just let me know by typing yes in the chat box. So for everyone is the voice audible, you can ask questions using the questions option. Yeah, so I think the voice and uh, screen is visible, so we can start the session. So thank you and we'll start it. So what will be my way of giving this presentation is I'll be explaining using the presentation as well as the software, and I'll be interchanging between the PPT and software. Also, I'll be taking some few models that I've developed or few models that I've created so that the explanation process is much easier. Now, till now, we have been using different kinds of support in our model and getting results, right? So we know how to use, when to use. What is the purpose of today is the background or the background knowledge of different supports so that you would get better understanding of how the behavior should have been and whether we are getting the expected results or not, right? So today's motive is the background behavior of our different boundary conditions. Or I can say in other words, background theory of the working or working principle. Now first on the foremost most basic support, which is our simple supports, right? We have been using this in our analytical models and theoretical calculations, simple support. What are simple supports? These are nothing but which restricts the degree of freedom of our nodes. Those are your simple supports. So if you go to boundary, define supports, you can see you will get the option of which degrees of freedom you want your constraints to be provided. Right? So we use this kind of supports when we want to provide fixity in our model. Right? We don't want any deformations to occur. We want full fixity. So we provide this kind of supports such as sphere bottom as I have written, or we can say when we have fixed beams, right? At those locations we provide. So these are the or at the bottom of our bearings when we don't model substructure, we just provide bearings. Then at the bottom of the bearings we provide fixed support. So at those locations we can use this. If I just show you an example, um, I'll just till that I'll proceed while we are opening it. Uh, yeah. So I don't think there will be any questions in this support. In the coming supports, I guess there would be questions. So yeah, let us see one by one. Next is very important and useful for a structural engineer point of view, and that is spring supports. And I'll explain why spring supports are more important for a structural engineer than geotechnical engineer in Midas, right? So in Midas Civil, as a structural engineer, we have very thorough knowledge of the behavior and understanding of how the structure behaves when we have different kinds of load. So self weight, moving load, and what is the bending moment diagram that comes. But when we have, but we don't have that thorough knowledge about how the soil supports are provided or what should be the stiffness in soil supports. Right? So to bridge the gap between structural and geotechnical engineers, so what we have over here is soil spring supports. So what here we do is instead of providing the exact stiffness according to the soil, we use basic soil parameters to calculate what would be the stiffness of the soil to simulate stiffness of the spring to simulate the soil conditions. Okay, so how we are doing this is, now let us say I have a pile support in my model, and for the piles we know there are transverse springs, there would be springs in the vertical direction as well, right? So we need to provide, there would be soil providing resistance in transverse direction, vertical direction, so we need to provide our soil springs. Now these are the, if we know the stiffness value, directly we can provide. But that is not the majority of case. Majority of cases, we don't know the soil spring stiffness. Rather, we know basic soil properties such as what is the C value, when I mean C, what is the subgrade of modulus, your phi value, C value of soil. Those are the things that we generally know for soil properties. So what we do is, I'll just show you. We have this particular option which is under boundary, integral bridge supports. So under integral bridge, you can see the different supports, abutment and pile spring. So if I take the example of pile spring, you can see you just have to provide soil type, what is the level of the ground, so you can tell where my soil level starts, and your pile diameter. And these are the basic information about your soil. So you can provide unit weight, earth pressure coefficient, and subgrade reaction, right? So based on these values, the software will calculate the stiffness values which would be replicating or simulating your soil behavior for the pipe. Why I suggest using this is a very good support conditions for your preliminary analysis, such as when we don't have the exact soil spring stiffness from our geotechnical engineers and we want to perform our analysis and design, that is preliminary analysis and design, we can surely go for the first analysis with using this soil spring stiffness, so that our results are very close to what could be in the site, and even though we are not using the accurate soil information. So I would suggest any structural engineers to go for a preliminary model using this kind of support, where rather than providing fixed support, you are providing some flexibility in the model by giving soil supports, that is spring supports, and this would be more better. So yeah, again, as we know that advantage of using spring supports over fixed supports, right? As we know, more the flexible your substructure or any structure is, lesser the force it will take, right? So by providing spring stiffness or providing spring supports, we are making the structure flexible, thereby reducing the force transfer in the structure. That's why we prefer soil springs than fixed supports to model our soil. Any questions in this? So let me just tell you how the soil springs are. So it is nothing but a simple spring support, right? So you can tell what is the stiffness value, and based on that stiffness value, force transfer would occur. Now, this is for general case. That is, you can see under soil springs, we have different types: compression only, tension only, multilinear. Now, we know soil doesn't resist if there are tensile forces. Yes, we have a question. Yeah, there is a question how to calculate modulus of subgrade reaction as per Indian code. So again, this information is something where we could get from the geotechnical engineer, and this would be like basic information of the soil that could be obtained after soil testing. Even I am not proficient in geotechnical engineering, so I don't know how according to Indian code it is calculated. But yeah, I'll check it out with my geotechnical expert and let you know. But again, this is some value that could be easily obtained from preliminary soil analysis. Maybe some soil test that is performed on the site, and we could input it. Or we can take some notional values or accepted values of your soil your subgrade reaction, which is generally for clay and those, and perform our first analysis, that is preliminary analysis. Now coming to next question, next thing. As I was saying, we have different types of spring supports: linear, compression only, tension only, multilinear. So multilinear is used when we have advanced soil spring stiffness information, right? We know that soil is a non-linear material and its behavior is dependent on the deformation that it happens, right? So if we have such a proper information about the soil spring stiffness, then we can go for multilinear, where we can define the force deformation curve and provide the spring stiffnesses. Usually the case is we don't have such detailed information about the soil spring, so we go for either linear or tension only. So what is tension only springs? It is nothing but the spring will resist only. Sorry, we will be using compression only springs, right? Because soil will not resist any tension forces, so we'll use compression only springs, and soil will resist only compressive forces. So how to use that? If you use compression only, you can see you need to provide the stiffness value and the direction, right? So this is the tricky part, which direction to choose for compression only. Now, if I just show you the help manual of this particular diagram, it would be more clear. So you can see over here, when I use compression only or tension only springs, there is a question, can a 20-30% of tension be allowed? Can you be more elaborate? Tension in terms of what? Stresses or what? Do you mean that in spring supports, can it resist 20-30% of the compressive forces? Something like that? Okay. Yeah, so I'll be explaining about this question, whether we can allow partial tension in our compression only springs, right? So I'll be focusing on that as well. For now, let us see this one, where we have compression only or tension only springs. So here only compressive forces can be resisted, and now you can see which direction to choose. So if my X and Z like this, and you can see I will be choosing dz minus. So my support will be at the bottom and my node would be at the top. So here I will be choosing dz minus, and I can give the stiffness that I would like and provide it over here. That is normal, right? Now there is a question regarding whether we can use allow some gap or allow some gap in the compression only springs. I'll be taking that question after the end of this session because it would little bit be different option than what I had planned for the presentation. So just remind me at the end of the session to come back to this question. Now the next thing is, this was regarding your compression only springs. Now let us say many engineers are involved with the box culvert modeling and box culvert designs, and the usual problem that they face is to provide the surface springs at the bottom. When I mean surface springs, we know that spring at the bottom is something like a UDL, right? When I mean UDL, it is distributed. When you use point springs, the springs when we use point springs, the different spring values that is taken is something like a nodal reaction should be provided by the point springs, right? So when we see the shear force variation at the bottom of our box culvert, or if we see the bending moment variation, it wouldn't be like we expected. Rather, it would be a zigzag behavior because the spring reactions are point as per point loads. But we want as per UDL kind of a distribution. So during that time, we use surface spring, right? And in surface spring, we have this option of distributed spring. So what this distributed spring does is, it applies the spring supports as if it is distributed rather than point springs. So you would get the continuous behavior of your shear force diagram and bending moment as per the soil behavior, and that would be useful. So you can select any type, that is you can apply for frame, planes, plate elements and solid. You can provide the width, a direction, and here again you have same properties, linear, compression only or tension only, and a subgrade of modulus, right? Uh, any questions in surface springs? What is the use of surface springs? So surface springs are used when we have any box culvert or any model where we want distributed springs at the bottom. So when we use this distributed springs at the bottom, we will get more uniform and more continuous changes in our shear force diagram rather than abrupt changes due to point springs. Right? So I think regarding soil springs, the major question is, what is the initial value of modulus of subgrade to be taken? That even I am not sure. I would have to check it and I'll let you know what is the general value to be taken. Uh, so there is another question: how to provide subgrade reactants if we have two types of soil? Uh, can you be more elaborate? Two types of soil. So is it layers? Two layers of soil, or is it okay? So when we have two layers of soil, Again, as I said, this is not the exact analysis, right? We are doing an approximate analysis to simulate the soil behavior, right? So when we have two layers of soil, we'll get the non-linear behavior of the soil. That is, based on the deformation, uh, what would be the stiffness by the soil. So when we have such details, that is when we know it is two layer of soil, we can model the two layer behavior in some geotechnical software. In case of Midas, we have Midas GTS NX. We can model that. We can apply those loads which is occurring over here, and we will be able to extract the multilinear soil springs. So you can see over here multilinear, and if you see, we can define force deformation function. So whenever we have more than one layer or whenever there is non-linearity in the soil, that time we would have to go for multilinear springs where we can have force deformation curves. So in that time, either we can use a single compressed stiffness value, which is your approximation, or you can go for more exact analysis by using multilinear springs. That was regarding springs in everything. Coming back to the PPT. So yeah, where were we? I just lost my mouse. Yeah. So now comes the spring supports done, right? Then we have the rigid link versus elastic link. Now this is a very frequent question and many users have it, and it's even a point of a good discussion for a technical point of view. We will able to learn a lot. What's the difference, why it is used, why there are two options, and what is the benefit of one over the other. So let us spend some time in these options because it will be useful when we provide bearings, when we provide rigid behavior between two nodes, and all other kinds of boundary conditions. So starting with, first we need to understand, let me just compare two different things which provide similar results. So everyone knows, I think here all have power users of Midas Civil, and you can see on the boundary, there are two ways of providing rigid links. Yes, there is one interesting question by engineer Mohit. He has asked, can we provide different soil layers? And based on that different soil layers, can we, using integral bridge support, will the software take the stiffness values? Yes. So you can select, let's say for pile, you can select the different types from here, which is we are having sand, we are having soft clay and stiff clay, right? So you can select the type, select the nodes, and the software automatically take based on the stiffness values. So that can be done. Yeah. So again, this we are going more into geotechnical point of discussion where SBC and other things. So I'll try if you have any such questions related to this, how we can come back. Just give me these questions and I'll ask my geotechnical expert to address these questions. So yeah. Moving on to the next support, which is elastic link and rigid link. So everyone would have used this rigid link to create rigid connection between my two nodes. Even in this particular model, if I just show you my rigid links, I have used rigid links to connect my top of the girder with my bearing nodes. So if I just show you in hidden view, you can see I have connected using rigid links the top of the girder and my bearings top node. And there is another way to do same thing, elastic link, rigid type, right? So what it does is it helps to connect between two nodes using rigid type of elastic link, right? Now the major question is there any difference between these two? Will the results be same? If the results should be same, what is the difference? When should we use which option, right? So these are the questions that generally arise from the users, and today I am here to clarify those doubts. First, let us understand how the behavior of these two links are modeled in the software, and then it would help us to understand which to use when. First question, excuse me. First thing is rigid link, right? Rigid link and elastic links behavior is, or the way it is principle behind its working, or the working principle is totally different. Rigid link works by constraining the degrees of freedom of your slave nodes according to master node. So if you see rigid link definition over here, you can see I select a master node and I tell the software which degrees of freedom shall be constrained of my slave nodes according to my master node, right? So when I select rigid body under typical types, all the degrees of freedom of my slave node is selected, constrained by my master node. So what I mean by constraint is that when my master node deformation in the x direction is 5 millimeter, my slave node is constrained to move in about the same deformation, that is 5 millimeter only, right? So that is what I mean by constraint. It is physically constrained using mathematical equations, right? There is no spring stiffness or no stiffness between the two nodes. Now let's come to second example of rigidity, which is elastic link rigid type. So if you click on rigid, what this software internally does it creates a spring between the two nodes and provides a very high stiffness between the two nodes, right? So it would model as if there is a very high spring stiffness between the two nodes and the two nodes would behave rigidly because of that high spring stiffness. So for all practical purpose, the behavior remains the same, but there is a catch. Now what is the catch? The catch is, now let us suppose we have a very big model where we have thousands of nodes. And when we have different elastic links and different rigid links what it does is, since it constrains the degree of freedom of our slave nodes with master node, it reduces the degrees of freedom in the model, right? Because now there are more constraints, so number of equations to solve is reduced. But when we have elastic link, it does not provide any constraints, rather it provides spring between the two nodes with very high stiffness. So your degrees of freedom is not reduced and the analysis time would be more than if you would have used rigid links. Now that is first difference between rigid link and elastic link. Second difference is how the behavior can, now there is some times where we want to provide support at my master node or slave node, right? So can I provide slave nodes at my rigid body node, right? So these are the some conditions that we encountered while modeling. That times we can't use rigid link. Why we can't use rigid link? It is because when we use rigid link, the slave nodes would have two constraints. What are those two constraints? First constraint is that it should deform according to my master node. Second constraint, it is that it should deform or its degree of freedom is restrained by my supports. So let us say I have restrained my x degree of freedom by providing define supports dx for my slave node, and it is that slave node is rigidly connected to my master node, which is moving a deformation in x direction by 5 mm. So the slave node is having ambiguous condition because it has to obey both the support condition and the master node condition. And since it can't do both, it will provide error message if we try to provide. I'll just show you an example. So I'll just open the message window. You can see over here. Now you can see my bottom node is slave node. I'll try to provide support. So I'll click on define support. I'll give group name sub. I'll fix all and try to provide support to my slave node and click on apply. Right now support is provided. Now if I try to run analysis, so you can see the warnings that is generated. So I'll just stop this, and you can see the warnings that are generated in command message. So you can see the warning is constrained degree of freedom and slave nodes are automatically released. Right? So that is what has been done. So this is what happens when you try to provide two different conditions to a slave node. So I'll just remove the constraint, and now if we perform analysis, it would be without any warnings. So that was another difference between my rigid link and elastic link. Now, third and the final difference is, as we all know, the behavior of the structure or the force attraction of different components is based on the stiffness value of the structure itself. So let us say I have continuous beams and there are two beams. So the beam which is more stiffer will attract more forces than the beam which is less stiff. Same goes for this rigid behavior. So sometimes what happens when we use elastic type of rigid link, due to the very high stiffness of the elastic links, it attracts more force and provides results which are not as expected. Thus, we suggest to use whenever possible rigid links rather than rigid type of elastic links, as it has very high stiffness and can take more forces than required because of its very high stiffness. Any doubts between the two options, rigid links and elastic link? Where is the use? What should be the use of this? Okay, no doubts. Okay, so I think this is very frequently asked question, and many of you would have already gone through the FAQs present at the global support. Now next we'll come to general link. Now this is the time when I would like to address question by Engineer Augustine. So there was a question, suppose there is a spring which is a compression only spring, and we would like to take some tensile forces by that compression only spring, right? So how can we model such a spring in Midas tool? So if you go to general link, and if you see general link properties, add, right? Do we have a question? No, right? Yeah, we have a question. Just a minute, Sandeep. I'll complete this, how to provide that, and then we'll answer the question asked by Engineer Sandeep. So yeah, we have this particular, as I said, the question is, can we, I'll just repeat the question for other engineers. So there is a compression only spring and we want to provide some amount of tension only in the compression only springs. So can we model such a spring in Midas? So the answer is yes. So we can use general link properties and add. So in under force type boundary nonlinear analysis, you have this two options, gap and hook. These are the two boundary conditions that we will be using to model that particular behavior. So as the name gap suggests, it is for tension. Let me just select it. So what gap does it? It will allow some kind of deformation. That is, if I just go to the properties in DZ, nonlinear properties, you can see you can provide some gap in the open, and once that gap is filled, it will start resisting forces. Similarly, you have hook the other way around, right? So you can see when D plus O is greater than 0, we'll have stiffness values. When we'll not have any stiffness value. When we have D plus O less than 0, we'll have stiffness values. That means till we have some gap, there would be no stiffness, right? As soon as we don't have any gap, there would be stiffness. Same goes for hook. Wait a minute. Wait a minute. Sorry. I don't think this option will be useful if you want for tension only. So if that is the case, we want to model tension only and compression only. So we'll have to use basic springs such as, let me go to point spring and I'll show you. We'll have to go to multilinear and we would have to define the multilinear force deformation curve. So you can provide when there is compressive in the model, what is the compressive strength, and when there is tensile, what should be your tensile strength, right? Sorry, my bad. I thought gap and hook springs could have been used, but no, that is having a different purpose. Yeah, next there was a question. Yes, when we are modeling substructure, we need to provide two reactions from bearing which link to prefer. So I think this would be a relevant case in this model itself. So this is, let's say, in this I have not yet modeled substructure, uh, but in this I have not modeled substructure, but I have used bearings. So if I just show you, I have 4 bearings. I'll just hide this. I have 4 bearings at the 4 ends, and I have modeled it using elastic links. So if you are going to model anything, if I am going to model bearings, elastic link is the right way because bearings provide some deformations and we need to find what is those forces it takes. So once I have used, I'll just show you the table. So you can see I have provided different bearings where stiffness values. So I can tell what is the usual value that people or engineers take when we don't have the exact stiffness values. So when we want to provide no degree of freedom in one particular direction, we take the stiffness value of 10 to the power of 8 kilonewton per meter. So when we want the no freedom of movement in that direction, we give the stiffness values of 10 to the power of 8. So you can see I have provided 4 different types of elastic links. One I have provided with all the 3 directions stiff, another one which is free in Y, third one which is free in YLZ, and last one which is free in ZRO. And you can see whenever I want freedom, I have not provided zero stiffness, but a very negligible stiffness value of 10 kilonewton per meter. 10 kilonewton meter per radian in rotation, and here 10 kilonewton per meter. And why is that is, since this is an FEA software or finite element based modeling software, what happens sometimes when we provide zero values, there can be an error due to numerical calculations, right? So there can be numerical error. To avoid that, we provide 10. And also, if you check the real life encounters, the bearings does not generally have zero value in other directions where we have guided or free bearings. It provides some resistance even in the direction that is free to move. So we can provide a very small value of 10 kilonewton per meter to avoid any such warnings. Now that is the case. So yeah, so here you can see I provided 4 bearings, and if under analysis results, you can see results table, I have elastic link option. So for elastic link, I can select my 2 links. I can select the load case for which I want my reactions. Let us select my ultimate limit state maximum reactions, and you can see the reactions that comes. So it is around 2722 kilonewton in almost all my bearings. So that is for your uh, bearings, how you can, which bearings to use. So that was regarding my connection between bearings and right. Now let's suppose we have some model where we have substructure. Now let me just open a model with substructure to explain it better. In the meantime, let me proceed with the session and I'll be answering those questions. I'll open the PPT, right? And this is a very important topic when we have any curve bridges or any skew bridge for an engineering point of view, and I like to spend some time on this. So yeah, any questions? Yeah, I had few questions. I'll be just taking that. So node local access, right? So this is one very important feature in Midas Civil for curve bridges and for bridges where we have any skew. What happens is in the curve bridges, we want to provide our supports usually in tangential or in the direction of perpendicular to my curvature, right? We don't provide supports in the normal global axis direction. So what we are going to use is node local axis, right? So I'll just open a model of my curve. So let's say I have such a curvature in the model. In this particular model, there is a very low curvature. But let's say due to this curvature, I want my supports to be aligned perpendicular or tangential to my curvature and not along the global x and y direction, right? So how can I do that? So the easiest way to do is, right? So there is two options. One is node local axis. So you can rotate your node local axis about any direction. So in this case would be Z. You can provide the skew angle and you can check your now it would be along your transverse or perpendicular to your curvature, right? So that is your node local axis. You have different ways to do that by rotating by angle, or if you have any 3 points, you can select 3 points, or if you have the information in vector format, the vector format. Now that is for your supports, right? So node local axis is useful when you want to provide supports which are tangentially or perpendicularly released or rigid, fixed. Next we have bearings, right? Let's see, even bearings we need to be modeled either tangentially or curved with perpendicularly released or fixed. Here you can see we have this option of beta angle, right? So you can provide a beta angle. So according to the beta angle, your bearings should rotate. So you can input the value and you can input the curvature or the rotation that needs to be provided and create. Now there is the question how to easily find what should be the angle that needs to be inputted. So I'll just show you an easy way that I follow. What we do is we go to tools, then there is, sorry, not tools, query elements. So if you query any element, let's say I'm querying this particular element number 21. So if you query on an element, these are the information that is provided. What is the material, property ID, beta angle, and also the angle to the, this is what we are interested in, angle to the global plane, right? So we have XY, XZ and YZ angles. So these are the angles that you can input and rotate accordingly. So in this particular model, it is not accurately rotated. So if I just change this particular rotation for this look elastic link. So if I just open elastic link table, right, let me just see the node number 10. So you can see I have not provided any beta angle. So if I provide a beta angle of 18.49 degree, I think it is different one. Let me provide minus. Right, now you can see it is much more aligned with my transverse and perpendicular to my curvature. So you can follow this for more accurate modeling of your bearings, angle of rotation or bearings inclination, how it is. Now there is a question about connection between your substructure, superstructure, what are the links to use. I'll quickly open one particular model file and we'll go through it and it will be very easy to grasp it. Where is that model file? Yeah. So here you can see, if I just show you in degree, this is the model file. I have a superstructure, I have a substructure, and I have a bottom foundation. Right? So if I just hide this and show all my boundary conditions, so you can see the same relation needs to be followed. First I connect my top of the girder to the bearing top by rigid links. So this blue color links are nothing but rigid links. Then I connect the top of the bearing to the bottom of the bearing with my elastic links, right? So in this elastic link, I'll provide stiffness according to my bearings. Then you can see this bottom of the bearing is connected with the pier or your substructure, pier cap, at the connection itself. Nodal connection is maintained. So if I just show you, the node number is same as, it is divided based on the pier. So you know piers are, the bearings are directly supported on the pier, right? So it would be as if there is full force transfer between your bearing bottom and the pier location. Same thing over here. And finally, you can see at the bottom I have fixed support for my pier foundation. So this is the general connections that we provide between substructure, superstructure, and Yeah, that was the thing. And then there was, let me just see. Uh, so yeah, when there was a question when we use any wizard, let's say steel composite wizard, right? So if we use bearing type, these values are defined by default. These are just for rigid connections. If you want to provide any other value, you can provide it. So it is as if there is rigid connection in all the 6 directions. So there is no guided or free movement. So if you want to change, you can change it and provide it accordingly. Next thing that I'd like to focus on is, so we have completed node local access. Now yeah, let's move on to frequently asked questions. Now this is a very basic question and we usually encounter it a lot. We have certain supports or links defined in the model and it is not applied when we are performing analysis, right? So this is very common question and we get such queries a lot. So what happens is, these are the basic reasons that could be behind it. The nodes defined within the boundary groups are not assigned to structure group. Uh, the nodes are itself not getting activated. The support itself is not getting activated, or the nodes, support nodes are not activated. So what does this thing mean, or this text mean? I'll just quickly explain in a model. So what happens here is, let's say I'll just go to, now here I can see different nodes, right? So what happens, engineers, what we do when we define structure group, we usually take only the superstructure elements. So what they take is, if I just assign minus, they usually assign only the superstructure nodes, right, and elements. So I've assigned all this, and when I perform analysis, right, so here you can see the error is coming. One major tip for all the users of Midas Civil is to view any errors or warnings that comes in the message window. It would help in understanding why the error is arising. So you can see on the message window there is boundary condition has not been active. So but in my base file I can see I have defined boundary conditions in this, right? Let me just go to CS1 and check it out. You can see there is no nodes of my rigid link and bearing nodes, hence the boundary conditions are not activated. So you can check like this, you can go to different stages and see if all the nodes and elements are active. So that would be my first troubleshoot method. So what I'll do is I'll add all these support nodes as well to my structure group. So I'll click on assign plus. Now you can see everything is there, right? So this is how you can do. Sometimes what happens, you have not defined, if you go to elastic link tables, here the group wouldn't have been defined. So it would have been default. When the group is default, it will not get activated in your construction stage. This is one reason. Another reason is, in your construction stage analysis, the boundary condition wouldn't have been activated, right? So that is another reason. Now the next question. Yeah, this is one another frequent question is, what kind of boundary conditions and elements are available in response spectrum and time history analysis, right? So we all know tension only, compression only, hook and gap elements. All these are um, all these are your, what to say, sorry, all these are non-linear boundary elements, right? So when you provide non-linear elements, what happens in tension only or compression only? It gets converted into linear elements. So when you have tension only, hook or compression only, this gets converted into truss. And for boundary conditions, such as tension only or compression only springs, it gets converted into general type of elastic link. Same thing with time history analysis. Uh, as I have mentioned for eigenvalue and stress response spectrum and boundary conditions again, it gets converted into general type of elastic link. Okay. So what happens is, let's say I have provided tension only strings, right? And tension only strings are provided, and I am performing. This is one frequent question that I receive is, while performing tension only strings, it is converted into linear springs in moving load analysis. And why is that? So there is one beautiful knowledge based article on this where it explains why considering tension only springs or compression only springs as linear springs in moving load analysis helps in reducing the effect in the overall load combination. As we know, moving load is always applied in accordance with the self weight, right? In any model, there can't be moving load alone and self weight will not act. So self weight will always act, which will make the springs always go in compression. So what moving load does it? Moving load provides relieving effect in our compression only springs. So if we don't consider that relieving effect, we are overestimating our forces that may arise in our compression only springs. Hence, for more economical design, it is recommended to not use tension only springs in moving load analysis. Uh, that is one point that I like to discuss. So yeah, any questions you have, we can have this question answer session. So if you have any mod where you had been modeling and you wanted to ask any boundary condition relevant question, we could see that. I hope I have covered all the questions that were asked during this session, right? Or did I miss anything? Okay, I have some questions right now. Uh, how boundary condition is to be activated in construction stage analysis? So boundary condition for activating, you need to keep three things in mind. First is all the nodes related to the boundary conditions needs to be assigned to the structural group that is getting activated in that particular construction stage. So here I had added my all these boundary nodes to my structure group. Second thing, all these boundary elements or boundary conditions needs to be activated or assigned as boundary group. So I've defined a boundary group over here, SUB, and you can see in my works, if I just go to rigid link tables, I have defined a group, assigned a group, right? And we even for all the groups. And third thing that we need to keep in mind is I have to activate that element. Here I have activated the element and boundary. So this is how we have boundary condition in construction stage analysis. Next question is, while modeling a pile foundation, is rigid link to be connected to all files or do we have, let me just see. While modeling a pile foundation, is rigid link to be connected to all piles? Okay, so this is the question. Yeah, so what happens is for pile foundation modeling, we have this theory of rivet theory, right? So what rivet theory says that it behaves as if all the forces are considered rigidly and it is transferring rigidly. So yes, if we have any pile foundation, it needs to be connected rigidly to at one center master node where our pier is meeting, right? So there will be pile cap. So we need to consider all the piles are pile tops to be rigidly connected to where our pier bottom is there. Next question is, do we have same boundary condition warning if construction stage is not defined? No, we will not have any boundary stage warnings, because if there is no construction stage, everything that is defined in our base model would be taken for analysis. So there wouldn't be any warnings for that. Then we have how to model friction of metallic bearing in the direction of its movement. Friction which has a relationship with axial load in bearing. Okay. So this is a very interesting question, because everyone who has been gone through code has seen this clause where we need to model the friction bearing for our bearings, right? So we need to model some stiffness. Now the solution for this is, what we do is, first we need to calculate, we model a dummy model, or else we model the same thing with a, what to say, without friction coefficient, right? So when we model it without friction coefficient, we get what is the axial load in our bearings. Once we have obtained the axial load in the bearings, based on that axial load in the bearings, we can model the friction coefficient stiffness. So this is like two-step process. First we'll model without friction coefficient stiffness, and then once we model it, we'll take the axial load value, we'll use that axial load value for our friction stiffness calculation, and then calculate the stiffness for my friction bearings. So even in first trial itself, the results will be satisfactory. If not, we can go for second trial. Then, right, so that was regarding friction bearing modeling. Same friction modeling only, it would be covered in that answer. And again, when the piles are founding in the rock or any condition, if you want to keep it as fixed support, then we can keep it as fixed. So usually we go for fixed support at the bottom of our piles, right? So usually that is the boundary condition that we provide, because we assume that pile does not, at the bottom there is no movement of the pile and it is almost fixed. Then there's another question. What is elastic link length shown in the wizard? So if you have been using wizard structure, steel composite wizard, there is an option of elastic link length. This elastic link length is nothing but the distance between the bearings. So between these 2 points, that is your bottom of the gear and bearing bottom, that is the two, that would be the distance between your elastic link length, right? Then so when we model using wizard plus manually, uh, you just have to make sure that all the boundary conditions, as I explained, this is to engineer Mohit, all the boundary conditions that I have explained, criteria is satisfied. That is, you need, if there is any new boundary conditions you are creating, let's say rigid link, you need to make sure it is assigned to the boundary group and it is getting activated when it is required in the construction stage. So that point needs to be kept in mind. Uh, yes, so as one practical limitation explained by engineer Jatindra, so he said that when we have for various loads such as SLS and ULS, axial load is varying in each case. So one stiffness will not work. That is right. So what we would be doing is, we'll not be doing for all cases, right? So we'll be just taking the critical case, because as an engineer we are not interested in the results of all the cases. We'll just do it for the one which is important for our design, and we can do it like that. So uh, as friction won't necessarily affect lot much, because it would be important for our substructure modeling. So first we need to make sure in our superstructure itself which is the critical case. So once we have finalized which is our critical case, then we can do for one particular stiffness. I hope this helps. There's a question by Engineer Yatin. I think this is more related to construction stage. So Engineer Yatin, I'll answer this question in the next session when we have our construction stage. So just have this question written down and I'll surely answer that. Uh, then we have, so I'll just try to cover all the questions. Hmm. And there is one question, can spherical bearing model in software? So Engineer Prasant has raised their hand. Kindly ask by asking using the questions option in the model. So you can do it that way. So again, any bearing can be modeled if we have the stiffness values. So spherical bearing also, just the same thing concept can be implemented. So I'll just confirm this. So there's no, it's not like spherical bearing and something else is different. We just need to provide the stiffness values. So Engineer Mohit is saying surface and pile spring is also added in group. If yes, then this spring at bar stage is activated. So what happens is, when do we want surface and pile springs boundary conditions to be activated? If we just think about it, the soil would be already present, right? So its effect will start coming as soon as the pile is activated, right? So as soon as you have the pile activated in your model, I think your surface and pile springs should be activated in the stage, right, Engineer Mohit? So yes, that's it from the questions, I guess. If you have any questions, you can ask me. Even later on, if you have any questions after this session and it suddenly popped up, you can just ask at globalsupport.midas.com and we will be happy to help you. So yeah, I think we have a final question. 7th September. Okay, this I have recorded this particular session's video, so this I would be surely sharing. The 7th September one, I'll just ask with my team and let you know when it will be shared. And today's video would be shared by today evening itself. And thank you for attending. And I hope you have a good day.